In the last video, I went through the derivations of these equations of uniformly accelerated motion. You can see the four equations there, and this last one, which is given by the total distance traveled equals average velocity or average speed multiplied by the time taken. Now the question is how do we apply these equations? Because they can give you one or two questions, and the examiner will not tell you that you have to apply equation 1 or equation 3 or equation 4. So how do we use these equations? Now to start with, you have to understand that when the question says that a body starts from rest, a moving object started its motion from rest, that you need to understand that the initial speed of the body, in this case, when the body starts its motion from rest, is 0. You will not be told this. The examiner will not even inform you about this. You're expected to know that when a car, an object, begins its motion from rest, its initial velocity is taken as 0. So you are going to include it as part of the parameters, the list of parameters you already have, you already know, in order for you to determine or to calculate the unknown. Again, when the body comes to rest, when a moving body comes to rest after the application of brakes, then its final velocity v is 0. So with this, because all these two will not be told you, the examiner will not even tell you that, they expect you to know. That's number one. Then number two is this. Then number three, you have to write down the parameters, the quantities, both known, the known and the unknown. And then after that, you go through the four equations of motion and then be able to look out for one of them that will have or that contains all the parameters that you have listed. Okay, let's take an example. Suppose you have this example. The example here says a body accelerated uniformly from rest at the rate of this for 8 seconds. A body is accelerated from rest at a rate of this for 8 seconds. Calculate the distance covered by the body during the acceleration. So let me start by writing down the known variables or parameters, including the unknown. So the question says from rest, that gives my initial velocity or speed as 0. Now, at the rate of this, they didn't mention acceleration in this question. That is, they didn't say with an acceleration of this. At the rate of this, that means since I have the unit, already know the unit of acceleration as meter per second squared, this 3 is my acceleration. So write it as 3 meter per second squared. Then time is 8 seconds. And then I'm to find the distance covered by the body during the acceleration. So I have 4 different variables in this from this question: the initial velocity, the acceleration, the time, and the displacement or distance. So I'll come back to my equations of motion. I have it here. Which one has UAST? UAST, this one, which means there's no final velocity here. So I'm going to skip equations that have final velocity. This will not be used, and this one will not be used. Even this will not be used, because this one has V as the final velocity as part of the parameters in the equation. So which one? I'm going to go with equation 2. And equation 2, from equation 2, half s equals u times t plus half at squared. So that I have s equals, this is 0 times t, which is 8, plus half times my acceleration is 3, times the time, that is 8 squared. So my displacement or distance covered, 0 times this gives me 0. That gives me half times 3 times 64. That is 8 squared. By the time I cancel, divide this by 64, that gives me 32. Then my final answer is 32 times 3. That gives me 96 meters. So the body covers a total displacement, total distance of 96 meters. Okay, so that's just an example. The next video, I'll take another example.